And that is excellent. There are certain caveats. You do need large document sets. I don't know exactly what this means. They don't have a strict rule for you. It just won't work. I mean, like it won't converge if you don't have a large enough document. And
sorry, large document set means a lot of documents.
That's right.
But not necessarily that long.
Sure. Okay. Yeah, that's right. Also, it is very computational intensive on the RAM side of things. So they say don't use it for vocabularies over 10,000 words. I can say that I tried once and it extremely crashed my computer. It was like not even Control-Alt-Delete. It was just I have to unplug it. So yeah, be careful. Yeah. I recommend STM. I'm sorry for not giving you the demonstration, but it's all there if you want to look at it and walk through it yourself. I want to go just briefly over the other topic models that have been used in political science. So if you have a specific task in mind, oftentimes, rather than just using LDA and running it, you should, write your own topic model. This is very hard, though. I'm going to talk about two of them that are very prominent. And basically, if you want to do the specific things that these models do, or something very similar, you should at least be aware of them and not try to reinvent the wheel or use a suboptimal method for the task that you were interested in. So there's this paper, AJPS, Quinn, I forget the other, Coloressi and Monroe, and one other fellow, but it's very nice. So what they're trying to do is look at speeches by members of Congress, and they say, well, we know about LDA, but LDA says that each document consists of lots of topics. We know that in this context, every speech is only about one topic. And so it makes sense for us to try to identify exactly what that topic is and not have as many different topics. And so they developed this model. They validate it very seriously based on both reactions to external events and individual members of Congress, what they're talking about, if that the assigned thing makes sense just by reading the speech, so they have external validation. It works very well. So this model is excellent. And they also find that these topics are clustered hierarchically in an interesting way. The graph on the next slide, I'll show you, let you know what I mean. So we have all of these documents on the x-axis, and we see both what percentage of the overall corpus they consist of, and this is basically a way of looking at how they covary. So the documents that are close together in the same cluster tend to be about the same thing. And so the model tells you both what the topics are, how prevalent they are, and what other topics they're most similar to. So yeah, if you're interested in a context where you're pretty sure it makes sense to have only one topic, I would encourage you to look into this method. And the other paper I want to talk about here is Justin Grumer's paper in Political Analysis in 2010. He's interested in expressed agendas in Senate press releases. So I actually think this is something you might be interested in when it comes to looking at how members of Congress communicate their desires to the people in their districts. So rather than speech on the Senate floor, which is somewhat strategic, I mean, press releases are strategic as well, but they're strategic in a different way. The audience is different. And when he's doing the modeling here, he clusters the documents at the author level. So in a way, this is similar to using a covariate in STM. I think that in the specific context, this would be better, but you probably would want to test both. So if you know the author of a document, which again, so in my example, which we have a collection of tweets from multiple authors, this wouldn't work. But if you know the author of a document, you can actually say that people tend to talk in a way that is similar to ways that they've talked in the past. And so when you're drawing from a distribution of words, you know that the words they've already used, and so you can incorporate that information into the model. And he's very serious about validating the results also. And so one really cool example from his paper is that he finds that members of Congress, senators from the same state tend to be very similar to each other in what they talk about, even more similar than Democrats and Republicans are to each other. So in general, Democrats and Republicans are similar to other Democrats and Republicans, but there's even more of a similarity between people in the same state, even if they're from different parties, which is
difference between what?
the way they talk in their
They being the two senators.
right. So this is like for each state, how much of a difference is there between the way people talk? How much of a difference is there in the way that one senator from that state talks and the way the other senator in that state talks? And we see that for most of the states, there is no real difference.
Except for New Jersey, Missouri.
Right. So in a couple there are, but yeah. So this is also an excellent paper that you should be aware of if you're interested in topic models. That's it. Yeah. Any more questions before we wrap up about anything?
Just really generally, can you motivated the STM by talking about the ways it overcomes some of the problems you presented on LDA?
That's right.
What, to your mind, are the remaining problems that STM can't deal with, or what are problems specific to STM? Like, what are the problems with STM? You presented that as like, aside from these like more specific applications on a case-by-case basis, it sounds like STM is like the way to go.
Right.
What are the problems with it?
Well, so they still haven't completely solved the problem of multimodality, and there is still lack of stability. I think the biggest problem has to do with the actual stuff you're putting in. So what choices you're making in terms of, are you stemming or not? Are you lemmatizing or not? What stop words are you using? Things of this nature.
Wasn't your question about why would you use LDA instead of STM?
No, my question was, what are the problems with STM?
Oh, okay.
Right. No. Yeah. So that's an interesting question too. I think in general, my biggest concerns are about that. And one thing I didn't actually talk about is, and that STM does but doesn't do perfectly, is allow you to actually look at the documents that you're using. So you should definitely read the documents that are assigned to topics strongly and make sure that it makes sense. You need to at least have some face validity. And there is a function in STM that lets you look at the beginnings of some of the documents. But you should absolutely make sure that like you have decided that that topic number 11 is the guns document and is the guns topic. And you should open up a high probability document that's assigned to that topic and read it and make sure that it's about guns. And if it's not, then you have a big problem. But you should at least take that step. When it comes to LDA versus STM, I think, well, LDA is faster. It works better on huge vocabularies. But I mean, in general, I'm an STM fanboy, so I'm about as good as I've got as a criticism.
Still, so one another question, which is, may not be that, I mean, in itself, it's good, but it's still unsupervised machine learning. So you cannot run regressions to predictions.
Well, you can use the output of LDA to run regressions, and people have. If you're interested, I've got a bunch of papers that use LDA, and a bunch of the papers I talk about here, they're all on the GitHub also. So
that means so those topics or the distribution of topics are what are like predictors or
yeah,
okay,
exactly.
You want to estimate something, their effects on
Or outcomes. I mean, you can just take the data that LDA or STM creates
Right.
and just put it into a data set.
Indeed. Yeah, so I use them as outcomes, but you can use them as predictors also.
I see.
So the Grimmer paper, I think, is about like how the political composition of your districts affect how much you talk about pork.
Right.
And it's like in this application, the DV is like the proportion of one topic.
Right, yeah.
Munger speech.
Exactly. All right, thank you guys.
Cool.